Today we are going to discuss consistency and inconsistency, predicate statement and quantifiers. So this is Dr. Sreekanth, the Professor, Department of Data Science, Institute of Aeronautical Engineering. Let us, what is meant by a consistency? Here, if H1 and H2 are any two statement formulas, then the conjunction of H1 and H2 has the truth value true for at least one possible situation. Then H1 and H2 is called consistent. So let us consider H1 we are taking as a compound proportion PRQ and H2 we are considering as negation PRQ. So these are the compound proportions. Now we are going to verify whether H1 and H2 are consistent or not. So for that, we are going to construct a truth table. So for all possible situations of P and Q, we have to verify at least one possible situation, H1 and H2 are true or not. True or not, that we have to verify. So here, first one is H1, we have to calculate what is the truth values of H1. And next, what are the truth values of H2? So truth values of H1, that is PRQ, we are computed, and the truth values of H2 also are computed. Then we find out what is the truth values of H1 and H2. So here, these two situations, observe these two situations, only this is true. That is, whenever P and Q both are true, and P and Q, one is false and true. So at this situation, we are going to get a true value. So we can say that H1 and H2 are consistent formulas. Then the next one is inconsistency. So inconsistency, this is quite opposite. That means for all the possible combinations, if we are going to get H1 and H2 are false, then we can say that H1 and H2 are called inconsistent formula. So here, H1 we have to consider negation P and Q. H2 we have to take P. Then we just calculate what is H2. And of course, H1 is already given. So it is a P. And just to simplify, what is the possible combinations of H1 and H2. So this is, let us consider this as H1 and of course this as H2. So all we are getting false. So we can say that H1 and H2 is called inconsistent formula. Now, let us, we are going to generalize this concept. So the set of formulas H1, H2 and so on, Hn is said to be consistent if their conjunction has the truth value T for some assignment of the truth values to the atomic variables appearing in H1, H2 and so on, Hn. That means whatever the atomic variables will be there in H1, H2 and so on, Hn. So for that, if you are going to consider at least one possible situation, H1 and H2 and so on, Hn is true, then we can say that they are consistent. And otherwise, they are inconsistent. That means all possible situations, we are going to get false. Then we are saying it is inconsistent. So for that, in the other way also we are going to prove this. So we are going to assume that, let us take one proportion R is true, and we are going to arrive negation R is true. Then the conclusion R we are taking as a true, and we are going to conclude negation R is also true. So which leads the given formulas are inconsistent because R is true and negation of R is true, which is meaningless. And this procedure is also called as proof by contradiction. Or we can say that the indirect method of proof. So proof by contradiction, whatever the conclusion we are going to prove, instead of taking that, we are going to take the negation of that one is true. And of course, we can get the conclusion. So we are going to assume, let us take the negation one is true. And obviously, whatever any premise is, we are going to prove that is false. That is also we are going to say that it is a proof by contradiction. Now, let us take the example. So here, we are going to show that the following premises are inconsistent. So there are four premises are given, and we have to prove these four statements are inconsistent. So observe this. These are formed by using four different atomic sentences. One is Jack misses many classes, and another one is he fails high school, and another one is he is uneducated, then he reads a lot of books, and he is not uneducated also will be there, already considered, and Jack misses many classes is already will be there here, and next reads a lot of books already there. So where these four compound premises are these four premises are collection of these four atomic sentences are primitive sentences. So we are going to consider those primitive sentences as E, S, A, H. So E is Jack misses many classes, S is Jack fails high school, A is Jack reads a lot of books, and H is Jack is uneducated. So by considering in this manner, by taking in this way, the given sentences we are going to take as like this. This is the first compound premise, and this is the second one, and this is the third one, and this is the fourth one. So these are the given premises we are going to represent in a symbolic form as like this. If E, then yes, that is if Jack misses many classes, then he fails high school. And the next another one is if Jack fails high school, if yes, then H. H is what? Jack is uneducated. So like that we have to consider. Like this we have to consider. So the thing is, so these AND operations that we are going to perform on this, then we are going to prove that. We are going to prove that. See, it is false, then we are going to say that it is inconsistent. It is inconsistent. Let us consider the first one is E to S. So this is the given premise. This is the given premise. So now the other premise is S to H. One is E to S and S to H. By combining these two and applying rule of syllogism, we are going to get E to H. If E to H is also true, because we are going to apply hypothetical syllogism. So far we are going to use only these two, and now we are going to take the contrapositive for this one is because the implication and its contrapositives both are equivalent. So instead of taking the implication, we are going to consider its contrapositive form. So that is a negation H, then negation E. So instead of taking 4, instead of taking 3, we are considering the equivalent form. Then we are going to consider the other premise. That is A, if A, then negation H. So now combining these two once again, if A negation H and if negation H, then negation E, and apply 4-5 rule of syllogism. Once again we are going to get this is the one. So 4-5 we are going to apply rule of syllogism. So now once again we are going to consider the equivalent form of this. The equivalent form is the contrapositive we are going to consider. So negation of negation E, that is E itself, then negation of A. So which is nothing but rule T. This is considered as 6 equivalent form. Then once again, we are going to write this is if P then Q. If P then Q. The equivalent form is equivalent to negation P or Q. Negation P or Q. Based on this, so this is the P is equals to E and Q is equals to negation A. So then we are going to write negation P or Q. Negation P or Q. So here also we are going to consider the equivalent form. Then once again, I took negation as common. Negation as common. So this is the 9th step. So negation is common. Then we are going to represent like this. So negation of E and H, E and A is true. Then we took negation. Then it is going to be true. Now let us consider the another one is the given the given premise which is given as E and A. E and A is true. And what we are arriving, negation of E and A is true. So subsequently, what we are going to get, P R is true, and we are going to say that negation of R is true, which is a wrong conclusion, which is a contradiction, so that the given premises are inconsistent. So in this way, we can say that, see, what we are going to consider, we are going to prove. So it is given. This is true actually, and we are arriving negation of this is true. That means whenever P is true, and we are going to get a negation of that premise is true. So P R is true and a negation of R is true, which is a meaningless. So which means that the given premises are inconsistent. Now let us consider the other one. So next one is show that negation of P and Q follows from negation of P and Q. So negation of P and Q follows from. So we are just taking in the other end. We are going to introduce negation of this is follows from. So instead of that, we are going to take as it is, which is the additional premise we are going to consider. So this we are taking instead of negation is going to be removed, and P and Q is true, or else we are going to take the assumed premise, which is the assumed premise. And here the given premise is nothing but this one is. So we are going to get negation P, it is given. So it is a P and Q. Whenever P and Q are true, then obviously P is true and Q is true. So in that way, we can take it as negation P is true. So from this, we are going to say it is negation P is true. Of course, negation Q is also true. And from this, we can say that P is true. So, which means P is true as well as negation P is true. So, which is a contradiction. So, why we are going to get a contradiction? Because if we took P and Q follows from negation P and Q is wrong. That means the P and Q will not be true. So negation of P and Q is true. Subsequently, we can say that negation of P and Q follows from negation of P and negation of Q. See, in order to show that the conclusion follows logically from the premises, we assume that C is false, and we are going to conclude negation of C is, we are going to assume that C is false and consider negation C as the additional premise. Negation C as the additional premise. So by using this concept, by using this procedure, we are going to take the negation of this. By using the negation of this, negation of negation is the premise itself. So we are going to consider the negation of C, the conclusion is true. So it is nothing but P and Q is true. And of course, this is given. So what we are going to arrive is nothing but which is a contradiction, because whatever we are assuming that P and Q follows from negation P and negation Q is false. So negation of P and Q follows from negation P and Q. This is the final conclusion of this. This is the other way that we are going to prove. That means this is the indirect proof, or else another one. Now let us go for, these are the things which are related to only consistency and inconsistency and method of indirect proof or method of contradiction. Now let us go for the other concept, the predicate and predicate statement function. In objective language, every statement has an object and a predicate. Every statement has an object and a predicate. See, what is meant by a predicate? See here, the part of the statement that describe something, the part of the statement that describes something on object is called predicate. That means describing about the object is called a predicate. See here, Suhas is a student. So here, Suhas is the object and is a student which is nothing but a predicate. That means Suhas, what is it is going to be something. That means Suhas is a student describing about the object, so which is a predicate. So here it is a predicate is a student is a predicate. So now we are going to represent this in a symbolic form. So the object we are going to take with a small letter, and the predicate we are going to take considered as a capital letter. See, object is yes. Let us take it as a Suhas, and the predicate is capital S, a student. So the symbolic form is yes in yes. So which is nothing but Suhas is a student. Next, the another one is discrete mathematics is a very important course. Discrete mathematics is a very important course. So here, what is the object is? Discrete mathematics is an object. And a very important course is a predicate. If I am taking discrete mathematics is a D and A as the predicate, then we are taking A, D is in A. So or else A of D, we are going to consider it as discrete mathematics is very important course. Now, observe this, the two examples earlier, whatever the examples we discussed. So there, S of S is there, A of D are there. So which are the predicate statements? A of D is only one object involved. Therefore, A of D is called one element predicate or one place predicate. Now let us take the two place predicate or two element predicate. So let us first consider the statement I is greater than Z. Now we are going to take the greater than is the predicate, And now we have to consider g of I comma j. So I is greater than j. I is greater than j. So now g of I comma j is called to predicate or to place predicate. Now we are going to combine one element predicate or two element predicate by using logical connectives. See earlier how we are going to combine the prepositions and how we are going to get a compound preposition. So similar pattern, similar way that we are going to combine the predicates, more than one predicate. Now let us say this. Suhas is a student and he is a bright student. See here, already we know another predicate. One is a student and another one is a bright student. So now, earlier one is yes, we are taking capital S is a student and small s Suhas. So we are going to represent this is S of S is nothing but Suhas is a student. And now another one is a bright student. B is a bright student, another predicate. This is another predicate. And Suhas is a bright student means S of B, which implies Suhas is a bright student. So this is one predicate statement. This is another predicate statement. We are going to combine. So by using the logical connective and. So here just we are going to take it as, just we are going to consider and, so we are going to combine them. So Suhas is a student and he is a bright student, which implies this is the symbolic representation of that. Now consider for the other example. Let us R is an object and yes is a predicate. A senior student is a predicate. Now S of R or R in S indicates Rani is a senior student. Now wears a sari is another predicate. Wearing the sari is a predicate. So W of R is Rani wears a sari. So now we are going to consider what is the compound preposition can be represented in a sentence form is Rani is a senior student and she wears a sari. And similarly, Rani is a senior student or she wears a sari. The second one. The third one is, if Rani is a senior student, then she wears a sari. So this is just a compound predicates that we are going to consider. Now, let us say, write a predicate statement of the following. One is, this shirt is red and Yadav is taller than Jadaks. So obviously, yes, this shirt is red. So shirt we are taking it as object and red is red. So we are going to consider it as a predicate. So R of S is S in R, shirt is red. So which is not correct. That means the statement it does not sound well. So we are going to sound well because of ambiguous meaning, such as shirt is red, etc. So we are going to rewrite this as this shirt is red. We are just calling like this. And this is the predicate statement of that. And the next taller than, which is one predicate. We are representing with a capital letter. And Yadav, see here what is given. What we have to prove is, we have to say Yadav is taller than Jadaks. Yadav is taller than Jadaks. So this is one object and this is another object and this indicates a predicate. So now the predicate we are taking taller than, and next Jadav is an object, and next Yadav is another object. So we are considering it as T of y comma z. So Yadav is taller than Jadav. So this is the compound predicate function. Now, what is a predicate statement function? What is a predicate statement function? See, predicate statement we say, that means a predicate is nothing but something we are going to describe about the object. Is a predicate. And now, predicate statement function, object is not specified. So Suhas or Rani or something else were earlier mentioned the objects, or Jadav or Yadav, something else. Those places are removed by a variable. Those objects are replaced with a variable. So then we are going to say that is a predicate statement function. So here, in this example, let us say S of x is a student. See, earlier what we are saying that S of s is nothing but Suhas is a student. Now we are going to replace Suhas, a particular object we are going to replace with a generalized word or a variable. That is nothing but x. So S of x is nothing but x is a student. This is called a predicate statement function, and of course x is called the variable. Now another one is g of x comma y. Earlier we discussed g of Yadav comma Jadav. So those Yadav and Jadav just replaced with other functions, so just variables as x and y. So we can say that g of x comma y is x is greater than y. So here x and y are variables. So this is represent a predicate statement function. So whenever predicate statement functions will be there, then if we are going to replace the variables with a specific value, then it will become a preposition and it will have a truth value. Suppose if I am just taking x is equals to 5, y is equals to 3, then g of 5 comma 3 is 5 is greater than 3. So this predicate will have a truth value. So 5 is greater than 3, which is true. And similarly, if I am going to give x is equals to 4, y is equals to 6, 4 is greater than 6, and it is having, this predicate is having a truth value which is false. And of course, earlier whatever we just taking the objects and we are going to combine. In the similar way, the predicate statement functions we are going to consider and we are going to combine them. So more than one predicate statement function, then it is known as a compound predicate. M of x is a man. P of x is precious. Then the compound predicate, M of x and A of x. So it is x is a man and x is precious. So in general, x is a man and x is precious. If you are going to remove that x, and we are going to say that man is precious. In another way, generalized the concept. This is a generalized way for the statement man is precious, that we are going to represent M of x and A of x. So this is a predicate statement function. Now let us consider some of these statements will be there. These are the three different statements, and we are going to convert. We are going to write the predicate statement from predicate statement functions. One is all men are precious. See this, for all x is a man, then x is precious. X is a man, x is precious. Can be taken as all men as precious. All men as a precious. And similarly, every tree is green. Means if x is a tree, then it is green. Then it is green. See, if x is a tree, then x is green. If x is a tree, then x is green. And next another one is all integers is positive or negative. If x is an integer, then it is either positive or negative. Is either positive or negative. So, just for any, see, observe this, for all. First one you observe this, all men. And the second one is every tree. And any integer. Any integer. See, for any, for every, for any. Observe this. We are going to notify, we are going to quantify whether it is all or some. We are going to mention the quantifiers. So here, the quantifier means we are going to measure the statement. Whatever the statement will be there, it is going to be true for all values of the variable, or it is going to be true only some values of variable, or at least one. So this is known as a quantify. We are going to measure for what type of variables it is true. For all variables it is true, or for one, at least one variable it is true, or some variable is true. So the quantify, we have to quantify. So quantifiers are two types. One is a universal quantifier or existential quantifier. So first one is universal quantifier. So here universal quantifier we are going to represent for every x, or this is, or we are going to represent it as like this, for every x. For every x this is, and this is for all x. Both are in the same way. We are going to represent either this form or this form. So that means, see here, if I am going to represent this is for every x. For every x. Let us consider some of the examples. Just we are going to mention the universal quantifier. So here, m of x and p of x. So x is a man and x is precious. In general, we can say that man is precious. Man is precious. So this is true. What I am going to say, for all values of x, this. So this is for all values of x, means all men are precious. All men are precious. Let us go for the second example. So earlier, whatever we discussed, the same thing, we are going to keep one quantifier. So this is for every x, t of x and g of x. That means x is a tree and x is green. So we are taking x is t for every x, every tree is green. Every tree is green. And next another one is if x is an integer, this is true for x is an integer, then x is a positive or negative. So this for every x, if n of x is true, then p of x. So we can say that any x is positive or negative. So this is a universal quantifier. Now the other one is existential quantifier. So the earlier, whatever the universal quantifier, this is true for all the variables, all the values of the variables. Now, here, suppose if it is true for some values, there exists a student in the hall. Some of the students are intelligent. Some of the teachers are dedicated. If you are going to express these statements in a symbolic form, we have to use the existential quantifier. So in the same way, just by keeping just by keeping. Say there exists X such that X is a student, and X is in the hall. Or there exists at least one student, X, at least one X, such that X is a student and X is in the hall. And in a similar way, there exists X such that X is a student and X is intelligent. Not all the students are intelligent, only some of them. So there exists at least one. Some means at least one, more than one. So at least one X such that X is a student and X is intelligent. Similarly, there are some teachers where there are, so we are going to represent, okay, we are going to convert into a symbolic form, there exists, okay, so we are going to represent, see here, there exists, we are going to take like this. If S of X is a student, see here, X is a student, and next X is in the hall is another predicate. So it is combination of two predicates. Then if X is a student, then he is in the hall. So here it is not true for all the cases, at least one. So at least there exists, at least one. So for that, we are just keeping there exists X, S of X, then H of X. So similarly, there exists X, S of X and I of X. Some students are intelligent, and here also some teachers are dedicated. So in that way, we can express, we can use the existential quantifiers and universal quantifiers. Now, see here another one is for all statement, all true. So we are going to represent like this. At least one is false. This is all true. At least. So we are going to take the negation. So we are going to take negation of this one. Or else at least one is false. One is false means only one negates there exists X. True F of X. So negation of F of X. All are false for every X. Negation of F of X. At least one true for every X and F of X. So just taking the negation of this, we are going to get all these values. So at least one. There exists X. Okay. Then this is the these statements are symbolic, the quantifiers that we are going to use. And these statement negations they are going to consider here. So negation of this. So I am taking negation of this. So all true, at least one false. So negation of for every there exists. And false, negation of F of X. F of X will be there. Then the negation is the negation of F of X. So negation of there exists for every it will be. So similarly negation of for every there exists. Negation of there exists for every. So here just we are going to consider the opposite, the negation, one universal quantifier and existential quantifiers are conjugates, that means the complements of each other. So that means we have to consider the converse of this or complement of this is nothing but then another one we are going to get. Now, negate the statement. We are going to consider one statement and we are going to convert into the symbolic form, and afterwards we are going to apply the negation, and after that once again we are going to convert it into a symbolic form. So whenever any negation of the statement will be there, then first of all you have to write in a symbolic form. Then that should be any conditional and biconditionals will be there, and we make it is free from conditional and biconditional, and we will see that it is having or and logical connectives, and after that we are going to take the negation, and after that whatever the things will be there, and we are going to convert it to a sentence form. So here, for all real numbers x, if x is greater than 3, then x square is greater than 9. So here, this is one predicate, and of course this is another one. So we are going to take p of x is greater than 3, and q of x is x square is greater than 9. The statement we are going to write for all. So for every x, p of x, then q of x, p of x, then q of x, which is equivalent to for every x, and equivalent form we are going to write. This is p to q, which is equivalent to negation p r q. So by using this, we are going to write the equivalent form, because the conditional we are going to eliminate, we are going to avoid the conditional, because the negation of the conditional, once again, it is not that much it can convert into the another form that is easy to represent in a sentence form. So for that reason we are going to take it as, and a negation of this, for every negation, then we are taking there exist, and the negation of this p of x and q of x, then we are going to convert it to symbolic form. So there exists, this is there exists a real number such that p of x is if p of x is x greater than 3, and negation of q of x square is less than or equal to 9. X square is less than or equal to 9. So this is the negation of the given compound given statement. So whenever the statement is given, try to convert it to a symbolic form, and see that it is free from the conditional and biconditional, and after that you take the negation, and after that once again you are going to convert it to a sentence form. So these are the topics that we for this session. So in this session we studied what are the when we say that consistency and inconsistency, and the indirect method of proof or method of contradiction, and the other is the predicate logic. In that predicate logic, what is a predicate statement, and what is a predicate statement function, and how we are going to get the compound of predicate functions, and how we define a truth values when if you are going to given a particular values to the variables which is in the compound predicate statement function, and next how to write the negation of that, and next what are the quantifiers will be, how we are going to represent the quantifiers, and what are the negations of the quantifiers that we have discussed. So these are the topics for these sessions, and thank you, Manda. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.